So hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our Rising Brain sheet, and you already know that Rising Brain is nothing but pattern wise DSA sheet, and in this we were doing the first array topic, in which we were doing the second pattern, which is sliding window pattern. And in this today we will solve maximum consecutive ones part 3. So in the last video we have already solved about maximum consecutive ones. If you have missed out, then I will definitely add some links here. From there you can go and revisit the question. And this question is nothing but another version of the previous question. So let's see the new question, which is maximum consecutive ones part 3. So you can see here the question says कि given a binary array numbers and an integer k. Binary array number means every number either it will be 0 or it will be 1. And you are also given an integer k. You have to return the maximum number of consecutive ones in the array. Okay. And if you can flip at most k zeros, means here in this question, if you see the first example, you first have to calculate the maximum consecutive ones, and then whenever you found any zero, you have right that you can change k such zero numbers. Okay, k such zero. So if k is equal to 2, so means you can flip 2 zeros into 1. And if you will flip these 2 zeros into 1s, then the maximum consecutive one will become 5 in this case. Correct? Similarly, if you will see from this part to this part, or this. So you can see in this sliding window, continuous window, 2 0 occurred, and 2 0 you can convert this into 2 ones also, like flip it. So it will become 6. Similarly, if you can consider this much 1, and this much sliding window can also be converted into 6 size sliding window after flipping 2 zeros into 1. So this is your task, and with this we can come on to our screen. So we are free to continuously count all the ones for sure, and whatever zeros are there, we can convert k such zeros into ones. So before moving forward, let's see the constraint also in the screen. So constraint gives n, like numbers length, array's length will be 10 power 5. Okay, so 10 power 5 means if we are thinking for brute force solution, then n square time complexity will not work here because it will go for 10 power 10, and you know that beyond 10 power 8 it gives TLE. Okay, and here it gives the k number can also vary from 0 to nums dot length, means k can also vary till nums size, array size. Okay, so what do you think? If you have to continuously count all the ones, for sure you will run a for loop, and whenever you are encountering any one, by default you will count it, correct? And whenever you will encounter any such zeros, okay, any such zero, you are allowed to take zeros, that is k number of time. Okay, so can I say if I run my I loop, I index from this 0 index, okay, and if this is equal to 1, no problem, I will move ahead. Again 1, no problem, I'll move ahead. Again 0, now I will count or increment my zero count variable. Suppose a zero count is a variable which will count how many zeros I have encountered. Okay, after incrementing this, I will check ki is my zero count is greater than k. Why I will check that? Because 2 numbers of k's are allowed, correct? 2 numbers are allowed, and here only 1 I have taken, so means I can take more. So now I will again move I++. Again I will say how many zeros I have encountered till now, 2, and k is equal to 2 means 2 0 I can flip, correct? So basically I'll keep on moving until my I hits third 0, or k plus 1 is 0, correct? So if my I hits, I'll stop here. Now I have to calculate what? Length. So how can I calculate length? So to calculate length, I should have left pointer at the leftmost, so that I can just subtract I minus L to get the length, correct? To get the length, yes. So basically what I am saying, instead of moving I pointer, we can move a right pointer ahead, and left pointer we will keep at the same location, so that in future we can calculate the length. Now to calculate the length, we know we do right minus left plus 1, correct? Right minus left plus 1, yes, but only when all right and left, both including right and left index, are valid. But you know we stopped at right index, third 0, which was not valid, correct? So this 0 we should have not taken it. So hence total length will be right minus left plus 1 and minus 1 for this R index because this is not the valid one. So hence minus 1 plus 1 will cancel out and we can say total length we can calculate just by right minus left. Correct? Yes. Now we have got our first length. First length means from left to this point. Correct? So now what we will do? Again we would like to move our left pointer ahead and again I want to start my right pointer from the same location and do the same calculation. Correct? Saying for every left pointer I will run my right pointer until this k number of flips I will do. Correct? If it will be more, then again I will start for new left pointer. So in this case, what will be the time complexity? Obviously, for every left pointer, we are moving our right pointer ahead. In this case, it is stopped here only. But what if there are no zeros? There are no zeros. Means, suppose there are only ones in our case. So in that case, for every left pointer, right pointer will run for all the numbers. Again, for second left pointer also, right pointer will run for all the numbers. For third pointer also, right pointer will run for all the numbers. So similarly, we will end up doing O of n square time complexity if we will go with this approach. What is that approach? This approach is nothing but running our left loop, means left pointer from 0 to what? N and left plus plus. Correct? And then running our right pointer from where? Left only from till less than n and then right plus plus. Correct? Now what we will do? We will check ki if nums of right pointer is equal to 0 means we have to check ki have we crossed the limited or k allotted flips. So what we will do? We will take a count 0 variable outside. So count 0 variable we will do plus plus. Okay? And after this we will check ki if this count variable 0, like count 0 variable is greater than 10, then we will what we will do? You just saw ki when our right pointer hit here and left pointer was here only. So what we did? After that, we don't want to move our right pointer ahead for that same left pointer, correct? We started the new left pointer. So means we have to break this for loop. We have to break this for loop if our total count 0 will be greater than k. Saying ki now for this one, k's are done. Again, start your new left pointer. Correct? Now what do you think? Before breaking, you should have calculated this length also. Correct? Yes. So what you will do? Before breaking, we will calculate the length and we will update in our max answer. So we will say max answer will nothing but math.max, maximum answer till now, or else what? Right minus left. Correct? Right minus left, because this is our current length. Correct? So at the end, after coming out of this all for loops, we will simply return our maximum answer and we will update our maximum answer with minimum 0, because obviously even if the num's length is 0, maximum answer will be 0 only. So that's why we will initialize with 0. So in this case, the total time complexity will be O of n square. You just saw in case of all ones where 0 were not present, so we took O of n square time complexity. But the constraint says the length can be 10 power 5. So n square will give you TLE there. So we need to optimize this. How can we optimize this? But before moving forward, let's see the brute force code. So in the brute force code, what we will do, we will simply calculate the num's length and after that we will initialize our max answer or maximum length. Then we will run the for I loop from 0 to n and j loop from that same I to n. Okay, we will initialize our 0 count and inside the j loop we have to check if the current jth index value is 0, then we have to increment our 0 count, and after that we have to check if the 0 count is greater than k, means the allotted k to flip was k and we are beyond that. So hence we need to stop there and calculate the length. So basically we will break here, or else there is one more way ki at every step you can just calculate the length. Why j minus I plus 1 here? Because in the next case when you encountered just k plus 1th 0, but in that case you are breaking, means in that case you are not allowing the length to be calculated. So hence in that case it would have been j minus I, but you are calculating this length one location prior to it. So this j is not the current j, this j is a previous j, and till the previous j the length will be j minus I plus 1, and at the end we'll simply return the maximum length. And you can see two for loops, nested for loops, so obviously it is going to take O of n square time complexity. Now let's discuss the brute force approach here. As you can see ki when we started from the leftmost pointer, so we started left pointer and right pointer together from here, and we kept the left pointer at the same location and tried moving the right pointer ahead. So we will simply move a right pointer whenever we are finding 1. So this was 1, so we'll simply move. Again 1, simply move. Again 1, simply move. 0. Now we will increase the 0 count, correct. Here again increment the 0 count. Here again increment the 0 count, and we can see ki after this position or at this position the 0 count has become 3 and number of 0 to be flipped allowed was only 2. So here we need to stop. Okay, and after stopping here you calculated the length, correct, you calculated the length. But when you calculated the length, then you started this left pointer from just next position, where you can simply see ki now the length which you are going to calculate will still stop at the same right pointer, and hence it will give you the minimum length compared to the previous one. Why? Because in the previous one when L was at 0 location, R stopped at the same index. Now even if you can see ki now if you move your left pointer ahead or at this position also or at this position also, you can see ki the length you are going to calculate will be minimum for sure. Yes, but why I said till here? Let's see. So basically when you moved your L pointer, you saw ki again you will move or stop at the same right index. So you moved ahead, okay, to the next. Again you saw ki 3 0. So basically we are not dependent on 1. Like answer will vary for the 0 value. Now when you moved here, you saw ki you still have 3 zeros and you are allowed to flip only 2 zeros. So again you moved your L pointer ahead like by 1 time. So now you will say ki okay, 1 0 2 0 allowed. So now if it is allowed, then you will move your right pointer ahead on 1. You will say yes, it is valid. Again 1 valid. Again 1 valid. Again 1 valid. Now you'll move to this 0. You will say no, it is not valid, because in this sliding window there are 3 0 occurred. So hence the total length will be this and this. So right minus left. That's it. So basically when we can see ki all these locations when left was still here, that was unnecessary calculation, because that will give us the minimum length only. So hence there is no need to run for that j loop for this time, and hence we will not move left pointer for this location to run R for it. No, we will simply move this left pointer ahead until it hits a valid index, and then only for that left pointer we will start running our right pointer ahead. So what I said, I will initialize a left variable from 0, and for answer calculation I will have my maximum answer or maximum count variable. Now I will run a for loop for what? Right index, and right will start from 0 and it will run till n and right plus plus. Correct? Now our task is ki if nums of right pointer is equal to 0, means at that case we have to do 0 count plus plus, and that 0 count plus plus we will update, we will initialize somewhere here with 0. Okay, now after that we have to check ki if this 0 count is greater than k, means the number of 0 which were allowed to flip was k, and now we have crossed that. So we have to stop here. So this time we were doing the expansion. Why expansion? Because our left pointer was here only and only right pointer was moving. So that was the expansion phase in the sliding window. And once we hit this 0 count greater than k, now we have to start the shrinking phase. Shrinking means now the left pointer will move ahead. Now the left pointer will move ahead. But before moving, we should have calculated the length also. And that calculation we will do out of this if case. And we will simply say maximum answer till now. So max answer till now and what? Right minus left plus 1. Why we are saying this plus 1? Because you can see ki when we will be at this index, when right is equal to 0, and that is k plus 1th 0. So we will come in this if case and here we will break. But we are saying break. So this if needs to be in a while loop. Otherwise, if we'll write break here, the whole for loop will get break. Correct? So instead of if, we will write the while loop. Now another reason why we used while loop, because we have to move this left pointer ahead until this zero count becomes equal to k or less than k. So basically you can see ki when you will move left pointer ahead, still you can see ki it has not crossed that zero, and still the count, number of zero count is 3 only. So basically again you have to move or shrink this left. Again it is not less than 3. Again you will move. Correct? So basically inside this while loop we have to do one more thing. What? Ki while moving we have to check ki if nums of left pointer is equal to 0, then what we will do? If 0 found, so our task is to decrement the 0 count, and after coming of this if loop we have to do left plus plus. Correct? So what will happen? Initially left was here. So basically we will check if the left index value is 0. No, it is not. So we will simply do left plus plus and we will move this left pointer ahead. Again we will check if no. Again we will check if it is 0. No. Again here when it will hit, we will check ki if this is 0 or 1. So it will say yes, it is 0. So if this is 0, we will decrement the 0 count, and now the 0 count which was 3, it will become 2. And after that, what do you think? We just saw that we have to move this one more pointer ahead, so that from left to right it will become k count. Correct? So that's why we will do left plus plus once again, and we will move this left pointer ahead. And now we can say from left to right we have only k values, 0 values. And after coming off this while loop, we can simply move our right pointer ahead. Correct? Yes. And now the length calculation will be done from this right to this left and not the initial left. And now in this case you can say the time complexity has been reduced from O of n square to not exactly O of n, but somehow. Why I am saying not exactly O of n? Because if you can see in this for loop, inside it also you are moving this while loop and you are actually running this left plus plus. And after that, to move this left pointer ahead, you have run this while loop for 4 times. So basically it is not O of n square, it is lesser, but it is still not the optimized one solution. But still, let's discuss this in the code. So here you can see we will simply initialize our left variable, 0 count variable, and maximum answer which we have to do. Correct? And we will run this for loop for right pointer from 0 to nums.length. And inside it we will check if nums of right is 0, we will simply increment our 0 count. And inside the while loop we have to check if we will hit the 0 count greater than k, now we have to shrink, and shrinking will be done for the left pointer. Correct? And that while shrinking also we have to check if the left pointer which we are leaving and moving ahead was 0, then to decrement the 0 count, or else simply do left plus plus. And after this if and while loop, our task is to calculate the maximum length, and that maximum length will be calculated by right minus left plus 1 here. And at the end we will simply return the maximum length. So if you will run this will definitely pass, and still it is better solution compared to the O of n square, and when you will submit this code it will get pass. So this was your Java code, and here it is with the same logic. Here is your Python code, and here is your C++ code if you are from Python C++ background. So what's the time complexity in this case? Of course it is not O of n square, but less than it. And what's that? It is not optimized yet. It is better solution but not optimized yet. Why I'm saying this? Because if you will see here, the R pointer starting from 0 index and running till n. Correct? And if you are saying inside it the while loop is also there, and that is nested, and that is why it is O of n square, no, it's not. Even if it is nested, but if you will see every right pointer is hitting or touching every index at only one time. Means R started with 0, 1, 2, 3 until n, it is running for only one time. Similarly, left pointer, even though it is running in the while loop, and suppose the left pointer started from 0 and it come here, but after that when R will move somewhere here, the right again will not start from here. No, the right will start from the same location where it is stopped at the last time. So basically it is nothing but R is touching every index from 0 to n, and left is also touching every index from 0 to n at only one time. So in total, n time complexity by right pointer and n time complexity by left pointer. So total O of 2n time complexity. Still we can say yes, it is nothing but O of n only. But what if I can tell you we can decrement, like decrease the time complexity from O of 2n to O of n also. That will be the better optimized way. Correct? Yes. So let's discuss the O of n time complexity solution here. Everything will be same, like how we have initialized a left pointer will start from 0 index only, and the maximum count variable will also start with 0, and 0 count we will also initialize with 0 only. For right pointer, how we made the new for loop, here also we will make a new for loop for right pointer starting from 0 running till n and right plus plus. And if we hit like nums of right pointer hit 0, correct, so at that time what is our task? Our task is to increment the 0 count, and basically we'll do 0 count plus plus, correct. After this we have to check if the 0 count is greater than k or not, because that is the case when we do the shrinking phase, correct. So what we will do, if the 0 count is greater than k, then basically initially we have put this in a while loop. If you can see here, we have put this in a while loop, and until this condition true, then we will keep on incrementing, and this we will not do here. So what we will do here, we will check inside, like if the 0 count is greater than k, means we have to shrink our phase, correct, we have to shrink. So basically we will shrink by left plus plus. And now what we will do, what if the left pointer we are moving ahead is 0? Like if the nums of left pointer, if this was 0, then though definitely we have to decrement our 0 count. Yes, we have to decrement our 0 count, and that is why this left plus plus which we did here, we have to do after this if loop saying left plus plus. Why? Because first we need to check before moving ahead ki if that was 0 or not, correct. If it was 0, we will decrease the 0 count, and basically we will put this in a while loop. Now let's see what will happen if we will put this in a while loop. And one more thing, if you saw here, we are not incrementing our maximum answer here, so that's why we don't need the maximum count also. Then how we will return our answer? Let's see. So initially we will start our left pointer from the same location, and right will also get started from the same location. Now our task is ki if this right pointer is 1, like if this is 1, then no worry, we will not do any of these things, and right pointer will keep on moving simply. So what we will do, we will move this right pointer ahead, 1 1. Now it will hit 0, correct. Now when it will hit 0, this if case will run and it will increment the 0 count. Now the 0 count will become 1. And is this greater than k? No, it is not. Now again this right pointer will move ahead. Now this k, like 0 count, will become k, but not greater than k. So again this right pointer will move ahead. Now at this position we can say ki yes, the 0 count has become 3 and we need to stop. We need to shrink. So earlier we were shrinking via while loop, but here in the optimized way I am saying just move this left pointer by one location. That's it. Stop. Only one location. Now again this right pointer will move ahead. Yes. And you can see कि still the 0 count is greater than k. Why? Because these 3 zeros are here na. So we want to move our left pointer that much time. But instead of doing in a while loop and keeping the right pointer to wait, that's what you did here. See, you waited the right pointer here and you run the while loop to move your left pointer ahead. We will do here also, but not via while loop. We will not ask right pointer to wait. We will increment our left pointer along with the right pointer. And if we will do that, then extra time complexity will not get calculated in this case. Okay. Now after moving right pointer, still the 0 count is 3 only. Greater than 2 means k. Yes. So again we will move this left pointer 1 point ahead. Okay, only 1 point ahead. Okay, now again we will move this right pointer ahead because of the for loop, and we can see that still the count is greater than k. Again this left pointer will move ahead. Yes, and now we can see still it is greater than k, correct. Now inside this, along with moving, we will check if nums of left is equal to 0. So we found that yes, it is equal to 0. So next time the 0 count will become 2 instead of 3. Correct. So we can, let's write somewhere here कि 0 count will become 2 now instead of 3. Correct. And again we will do this left plus plus. So this left pointer will move ahead. And now again the right pointer will move ahead. Until now, sorry, I think I missed one more case. So we will move here. Okay. So now till now we can say कि okay, what is the length? Whatever is the length, but we are not calculating here. We are actually finalizing ki what is the best location for left pointer when right pointer hits the last index. Okay. Now left pointer will wait here and right pointer is here. And you know we will increment the 0 count only when right pointer hits the 0 value, and here it has not hit. So we will increment the right pointer. again it is not 0, again it is not 0, again it is not 0, so only right pointer will move. Now here it is 0, correct? So now here it is 0, again the 0 count will become 3 from 2, and since the 0 count has become 3, so this if case will pass, saying ki yes it is greater than k. Now our task is to move our left pointer ahead, but first check if this is left pointer is equal to 0. If it is equal to 0, we have to do 0 count minus minus. So again the 0 count will become 2 from 3. So this left pointer will move ahead at this location. And now after this we can say that the for loop will stop because the right index will go out of bound. And what you can say, what is the exact or correct length? So you can see in this range we have only exactly 2 such zeros or k such zeros which we have to flip. So what is the total length? Total length is nothing but, if this right index was valid, then right minus left plus 1. But as you can see, right is out of index, so hence total length will be right minus left. So basically, instead of the while loop, we used if loop. Here also we moved this left pointer from this location to this location. But we have not forced this right pointer to wait for that time. When right was moving, meanwhile, we have moved our left pointer also. So hence total time complexity is exactly O of n in this case, and that's why it is the most optimized solution. So I hope this was clear, and after coming off this while loop, we will simply return the right minus left here. Correct? So without wasting our time, let's start writing our code. What we want a left pointer, so we will initialize the left pointer with 0, and we want a 0 count. Correct? So we will initialize the 0 count variable with 0, correct? Now we want a for loop for right pointer. So for right pointer, we want a for loop to initialize with 0 less than n. What is n? Nums of length. So we can simply do nums of length. Okay, now write plus plus, correct? And this nums of length we have to calculate. So here we will do int n is equal to nums dot length also. Correct? Now inside the for loop, what we are supposed to do? We have to do ki if our nums of right pointer is equal to 0, at this location we are supposed to increment our 0 count. Correct? Yes. Plus plus. Now we have to check ki if our 0 count has somehow become greater than k. So now what is our task? We have to do left plus plus. Correct? Left plus plus. But before doing left plus plus, we have to check ki the shrinking phase which we are doing for left pointer, if at that position it was 0, then our task is to decrement the 0 count. Yes, yes, to decrement the 0 count. Correct? And after coming out of the whole for loop, we can simply return what? Nums dot length, which is right pointer, because right pointer after coming out of the for loop, right pointer will be pointing to what? Last index plus 1, and that is nothing but nums dot length. So we can say n, and the left pointer it is pointing to, we will simply run that because that is the valid length and that is a maximum consecutive length. Okay, so sorry, spelling is wrong. So now let's run this. Again same here also. Yes, now it's running, and let's submit this code. And you can see it is almost 99.86. Somehow the previous code was also fast because it was O of 2n and it is nothing but linear only, but it is more optimized solution. Okay, so this was your Java code, and with the same logic here is your Python code. If you are from Python background, then this code will be helpful. We have not changed anything. Whole logic is same. Only the language matters or differs. And with the same approach, here is your C++ code if you are from C++ background. So I hope you understood brute force, better solution and the most optimized solution. If in the interviewer asks you, start with the better solution and then go for the more optimized solution. If after saying for the better approach you have used O of 2n, and if the interviewer asks you to further optimize it, then definitely he's asking about exactly O of n solution. So now along with this, we can go in our Rising Brain sheet and we can mark this another question in our sheet. So what is this sheet? This is nothing but DSA pattern wise series which we are following in our full playlist. And if you are new to this channel, you can definitely check it out, all the links of the DSA pattern wise series also. And if you want to connect with me on Instagram, LinkedIn or any other social media platforms, all links will be there in the description below. So I hope this video was helpful and you learned something from it. And with this, we can wind up this video. Let's meet in another video with some more interesting question. Till then, keep learning, take care of yourself and your family.